Chapter 1, Section 4, Learning Target 4, is about using equations to calculate distance, time, velocity, and acceleration. As we've learned before, equations can be used to represent motion. In this situation, we are talking about acceleration equations. Acceleration is the change in velocity divided by a change in time. Acceleration is also the slope on a velocity time graph. So when you find the change in velocity divided by the change in time, you are finding the acceleration. And we can use these symbols: change in time, change in velocity. So we can rewrite this equation in words into this equation using symbols. Again, this is what the symbols mean. We can then rearrange that equation to find other pieces of information we might be looking for. If we want to know what the change in velocity is, we can multiply acceleration by time. If we want to find out the time measurement, we can divide the change in velocity by the acceleration. So in other words, these are the symbols in the equations that you can use to find either acceleration, velocity, or time. It all depends on what you're given in the problem. These are the items you are given, and these are the items you're trying to find. Another way of solving the problems or manipulating the equations is using the circle method. We've seen this before with the velocity and speed and distance and time. Now we are substituting in for the acceleration variables. So we have acceleration in this quadrant and change in time in that quadrant, and then we have the change in velocity in the top half of the circle. In order to use this, remember mathematically, if one thing is above another, you divide. If things are side by side, you multiply. The way you use the circle is also described here. You can use either equations or the circle method, whatever makes the most sense to you, as long as you show your work. Here is a sample problem. The problem is described here. What you want to do first is locate the key pieces of information in the problem. So at the start of the race, the toy car increases from 0 meters per second to 5 meters per second. That's this change in speed. The time measurement is given to you right here. 0 seconds to 2 seconds. What do you want to find? It says to find the acceleration of the toy car. So, using the definition of acceleration as a change in velocity over change in time, we first write down what we're given in the problem. We know the final velocity is 5 meters per second. The initial velocity is 0 meters per second. The final time is 2 seconds. The initial time is 0 seconds. Then you can choose the appropriate equation. We are trying to find the acceleration. We know the change in velocity and the change in time. So this would be the equation we would want to use. To figure out the change in velocity and the change in time, we need to do some math. We need to subtract the initial velocity from the final velocity, and we need to subtract the initial time from the final time. We get the answer of 5 meters per second divided by 2 seconds. When you do that division, you get 2.5 meters per second squared. Meters per second squared is going to be the unit you use for acceleration. Here we have a practice problem to use, and we also have a structure to help us with our organizing of problem solving. So you'll use this grid to make sure that you are correctly solving each problem. In this practice problem, you see a race car is leaving the starting line and accelerating at a rate of 8.3 meters per second squared. So we are given the acceleration, 8.3 meters per second squared. And the race car is accelerating to a speed of 75 meters per second. So the final velocity is 75 meters per second. VF means final velocity. The starting velocity, the original velocity or initial velocity, is 0. We can assume that the race car is at 0 meters per second when they leave the starting line. So what do we want to find? We would like to find how long it takes. So that means time. We are looking for the time measurement. We need to decide on which formula we want to use. If we are trying to find time and we use the circle method, we know that acceleration is here, velocity is here, time is here. So we would use the acceleration and the velocity, divide the velocity by the acceleration to find the time measurement. If we're using the equation method, t equals the change in velocity divided by the acceleration. So when we plug in what we know the velocity is 75 meters per second, because from 0 to 75 is a change of 75 meters per second. And we know the acceleration is 8.3 meters per second squared. So when we do the division, 75 divided by 8.3, we end up with 9. And when we cancel out our units, it's kind of tricky, but meters per second divided by meters per second, that's really what meters per second squared is. We can cross out the meters per second and the meters per second. They cancel out. And so you're left with just seconds. So our answer is 9 seconds is the amount of time it would take for the race car to go from 0 to 75 seconds at that rate of acceleration, 8.3 meters per second squared. We can plug things in to check. So if we plug in our time measurement of 9 and we have 8.3, we can multiply those numbers together to see if we get 75. It is always important to check your work to make sure that you have done your math correctly. It's also a good idea to double check the units just to make sure. We have meters per second here, meters per second squared here. Our time measurement should be in seconds. If you end up with some other units of measurement like meters or meters per second, then you know you've done something incorrectly, because time should always be in seconds or minutes, some measurement of time. Now it's time for you to do some more practice. Thank you.